Hey folks, so I just have a few more things I want to discuss on the topic of ADTs. So first of all, right, we've already gone through basically one big example of them. So you've done point2D, right? Point2D was an immutable class. Now there are other ADTs, right, you've already seen, right? So you should have already seen a stack, a queue, and a list. These are ADTs you have seen in your previous courses. You also have used a couple other ADTs. The biggest example, which people forget, is string. So string is actually an ADT. A lot of basically the complex types that you've used from the Java library, those are ADTs. So you already have used these a lot, but these are kind of, so these are what I call like that dynamic ADT, that static ADT, right? Where it's just like, oh, it's one thing that stays the same, right? It doesn't regenerate themselves. Point2D, right, is kind of dynamic, right? So point2D isn't dynamic as it stands. It is immutable though. So immutable, right, means it doesn't change. So if we wanted point2D to be something that was this dynamic type, what would happen is it would have other functions inside of it. Like for example, we might have something that says like scale, right? And scale would take in a scalar, and it would return to us a new point, right? Which has x and y doubled or whatever, right? Whatever the scalar tells us to change, right? Then that would make it a dynamic type. As it is, it's all kind of it doesn't have any way to regenerate its own type, right? It doesn't have any transformations, and so it's not dynamic the way I described it, right? It kind of just is still a static one, right? But it is immutable, which is nice because we don't have those reference issues. Now, if you want, you can go on the book's website and find a few more examples of ADTs. So the ones on the book's website are basically these over here, interval 1D, interval 2D, as well as accumulator. So those, right, you can take a look at online if you want. I believe one of the interval ones is also described in the text, although we won't do it in the slides here. For even more examples, you can go and actually look at the sample source code for a class. If you look kind of at the next area of content, which is going to be sorting, you'll find actually examples for a date class, right, which stores month, day, year, as well as a transaction, which basically stores a date plus a price plus a person. So if you want more examples of ADTs, you can go check those out. Those are on the repository online. All right. So implementing ADTs. We're going to use a class, right? Again, how else do we do it, right? We're going to implement it with a class. Main thing here, right, is when we do the implementation of these things, is that our documentation, right, is really the gold standard, right? So from the outside, right, somebody using your API, right, isn't going to glance at your source code. All I see is the function signature, a method signature, and then the documentation. Well, that means that when you have that stuff, right, you need to follow it exactly, right? So it's the documentation, right, that goes to both the person who uses it, the person who implements it. It's the only kind of common language between you. So as an implementer of these things, right, you need to make sure that you are implementing exactly what the API says. The API says do X, you do X, right? You don't do X prime, you do X itself, right? You have to do this very specifically because somebody else, right, only has a documentation to go off of, right? So that's what so that documentation is actually listing, right, the behavior that they expect. All right, so that's it for now. In the next kind of chunk of content, we'll talk about some more details in terms of implementing ADTs.